All right. Here we go. So, we're gonna go on a ride. Hopefully, we will arrive somewhere. Okay. Okay. So before we even talk about recursion, I just want to talk about functions, and I want to talk about something called the stack. Okay. So when we create I have two functions here. One that just says say cool and one that says say hello. What I want you to notice is that say hello actually calls say cool. All right? And as I'm saying it out loud, I realize these are weird function names, but whatever. It's not important what they do. It's just important that I have two functions. One is calling the other. Cool? Okay. And then down here, and now remember, when I define a function, that doesn't do anything yet, right? I have to call that function in order for something to happen. So on line 15, I'm finally calling say hello, right? Say hello calls say cool, okay? So now, when this happens, your interpreter has something called the stack, where it keeps track of, and I'm gonna vastly simplify it. It's way more complicated than this, but I don't even really 100% understand it. So this is just an overview of how it works, right? But it has something called the stack, where it keeps track of processes that it's trying to, like functions that you call, basically. Let's just keep it really simple, right? And whether or not they have been resolved, like whether or not that function is done doing everything it needs to do, okay? So when I define these functions, that's fine, it reads those. Then on 15, I call say hello. So the interpreter looks up, oh my God, there's a function say hello. Let me look up and find the definition for that. And it finds the definition that I have on line 11 here, right? And then it starts to execute that code. So line 1 is just my definition, or line 11 is just my definition. Then on line 12, print is actually a function, right? So then it needs to run line 12, and then it needs to call say cool, which is another function, right? So let's walk this through. So if I have my stack here, and the way it works with the stack, and stack is also a data type that we can go over. But the way a stack works is like it's like pancakes, right? The first thing or the last thing I put on top is always the first thing I take off, right? So in this case, very simplified, say hello gets called, right? So the interpreter adds say hello to the stack, right? And it's like, okay, cool, I need to keep track. This is not, just think of this as like things that are running but not done yet. Cool? So say hello is here. Then it looks up say hello and it says, oh, there's print. I need to run print, right? So then it adds print. It probably looks up, there's a definition for print somewhere in the Python code, right? And it executes that. And it reads this line, and it says, okay, I can't do anything until I say print. Once it finally prints hello to the screen, this gets removed from the stack, right? So it gets added and then removed. But say hello isn't done processing yet. We haven't done everything that function needs to do, so it's still on the stack. Following me so far? So then we get to line 13. Oh, call another function, say cool. Great. Say cool gets added to the stack. We jump up here, now we're in the say cool definition, which calls its own function, print, which gets added to the stack. Print gets executed, it prints cool. Gets removed. Now we jump back down. There's nothing left for say cool to do. Say cool is over, right? It only prints one thing. That's gone. Now I'm back in say hello, because it's the last thing on the stack. And, oh, we're finally done with say hello. There's no more lines of code. And now say hello is gone. And we finally completed that stack. Okay? So the biggest thing that I need you to understand, or we need to understand, is when I have a function with a function inside of it, say hello is not done running until say cool is done running. Right? It has to wait for say cool. If say cool never finishes, then say hello will never finish. Okay, that's key to us understanding how recursion works. All right. Okay, so now how does this matter with recursion? What does this have to do with recursion? Let's take a look at. I think for me the easiest function to understand recursion is factorial, so I wrote it up here. Let's blow it up real big, because I'm going to try to write it on the board. All right. Okay. Oops. All right. I think I'm not handling any edge cases here, like if someone put 0 in or whatever. I don't actually. No, this one won't. But this is the basics of the factorial of recursion, okay?
You put less than 1.
So, yeah, less than 1 would do it, right? Okay, I gotta fix that in a minute. So what is factorial? What is a factorial of a number real quick? So if I want the factorial of 5, it's 1 times, right? Times 2, times 3, times 4, times 5, correct?
It's actually 5 times 4.
It's not, doesn't matter.
Oh, it's the other way. It's the other way. Right. And actually, that's how it's going to work. So that makes more sense. Yes. Sorry. 5 times 4 times 3 times 2 times 1. And I believe this equals 120. Cool. So this is what we ultimately want to accomplish. And we could do it with a loop. You probably already solved it with a loop. Maybe you did. But we can also solve it with this idea of recursion. And what all recursion is a function that calls itself. That's it, right? It has some things that needs to happen when it calls itself, but that's what we're talking about. It's a function that calls itself. And that's what we have right here, right? So I have defined a function factorial. It's taking in 1 argument. If that argument equals 1, it returns 1. Otherwise, it multiplies the number of times, and then it calls factorial again, but it calls it with the original number minus 1, right? So there's 2 things that we need to have when we have a recursive function. 1, it needs to call itself. 2, it needs something called a base case. A base case is my out. So in my loop, when I loop with something, if I don't tell my loop when to stop looping, what happens? It just never stops, right? Infinite loop. Same kind of idea with recursion. If I don't tell my function, it can call itself all at once, but I have to tell it at some point, you need to stop, right? And if I don't tell it to stop, then I'm going to get what's called stack level too deep, which means it's that stack that we talked about is going to have factorial so many times that it can't keep track of it. Okay, so let's walk through with, I don't want to do 5. What is the factorial of 4? 24. Thank you. Let's just do 4. We don't have to do so many steps. Okay. So let's walk through this function and how this is working with as far as the stack and why it's or how recursion works, right? So let's say I call I'm going to call fact with 4, right? So I call it once. Can everybody see what I'm writing here? Okay. So I call fact with 4. So let's walk through my function definition. What happens on line 1? What do I do? Yeah. Well, I check what is num on line 4? 4. It's 4, right? What I put in. Is num equal to 1? No. So do I run line 3? No. So I run what? Line 4, right? Which does what? So then I have, so basically I'm still in this first call, and let's check our stack too. Cool. That's been added, right? Okay, so I'm going to call fact again, but what I'm doing in here is I'm actually saying, so 4 times fact 4 minus 1, right? So now I'm calling fact again. Cool. So the important thing to understand is this first fact right here, it's not done running. It's still on my stack. In fact, I have something above it that's taking precedence, which is fact with 3. Cool. Same exact thing happens, right? In fact, let's just put 3 here, so we know. Well, same exact thing. I get to line 1, doesn't run, right? Or doesn't? It's false. Doesn't run line 3. So now I'm on line 4 again. I've run this same thing. The only thing that's kind of confusing about this is I keep entering the same definition, right? And in the same definition again, and I'm running that same logic. And so by this logic, what I really want to do is say 3 times fact 2, which gets added over here. Cool. Questions? All right. So our last, now we're finally going to hit our base case. And the base case is when I want it to basically stop running recursion. I have to have some sort of case in my definition where it doesn't call itself. If it's always calling itself, it'll never stop. So at some point, my definition has to stop calling itself. And we're finally going to get there, right? So, actually, we're 1 away. So we'll go, so we call fact with 2. 2 does not equal 1, right? So we call it one more time. Wait, sorry. So now I want, trying to follow my line. This should be 2 times fact of 1, right? And then fact of 1 gets added here. And then finally, return 1, okay? So is everybody clear about how we got all the way down here? Okay, so we need to understand, like, we've dug all the way down and we have not returned one single value yet, right? And the stack just keeps adding. Cool? We finally have gotten to something that does, it's not calling itself, it's not calling a function anymore, it's just returning something, right? So now that we can return 1, this is finally done, right? Because it's finally returned something. So it kicks 1 back up. So now fact of 1 returns what? 1. So I can erase this, I can erase this. And so now I'm at return num times whatever fact of 1 returns, which it finally returned. So now I'm at fact of 2 is 2 times 1. So that's what this is going to evaluate to, and it gets removed from the stack. And this becomes 2, right? Same idea here. This finally resolves, becomes 6. This gets removed from the stack. And then at the very end, I have 4 times 6, which is 24. And so at the very end, I get 24. And I'm finally done. Cool. Super confusing. I hope that was at least a little bit helpful. Please ask me any questions that you have now. Yeah, go ahead.
What happens if you, in the last line, you use return?
If I don't put return here?
Yeah.
Then it's going to, I think it's just going to return nothing.
Yeah, it defaults to nothing.
So it won't, so it'll still, I think it'll still do the recursion, but like when it gets to 1, I think you might end up just with 1, is what I kind of think.
Say it again.
I think let's just test it.
I think it's going to return none.
I think it's going to, yeah, none or 1. The whole key to this is like, so when we were all the way down here and we finally got to 1, it returned 1, but then when we were on 2, and it was like 2 times 1, if we don't return this value, it won't, the next function won't get it. The next function won't get it. Yeah, Kristen.
I think the best way to explain recursion is the towers of Hanoi and how it works.
The what?
The towers of Hanoi.
Go for it. I don't know what that is.
Let me Google and
Okay.
then send you a video because it's a lot easier, and then this makes a lot more sense because when I try to understand recursion without towers of Hanoi, it was just like, what is happening?
Yeah.
The way that you explained it is actually very well, but
No,
beneficial.
you're gonna have to encounter it a few times. I had to have it explained a bunch of different ways to really fully understand it. And you're gonna mess with it today a lot, so hopefully you'll start to understand the ins and outs of it. Yes.
I was just gonna say that, like, to me, factorial is actually a more complicated example than some examples of recursion, because it's just like a function that calls itself till it doesn't, right? So, like, what's stopping you is dependent on variables that aren't in your recurring function, then it's really easy to make it stop. Like, you have a function within a function, and you have access to all the variables within that function, or variables in your global scope. It'd be really easy to make a function that calls itself and then stop based off variables that are in the scope above it.
Sure. Yeah. I mean, if you had a larger program. Yeah.
Yeah.
The only
you
time
could probably use a loop for any problems that you could use that way of recursion. I'm just saying that's a simple.
Yeah.
You will not use recursion that often, especially in web development. Like, you will not, but you'll get asked about it in interviews, for sure. So it's important to understand it, right? The only time I've ever really used it is like, when I want to learn a new thing, I usually build like a game. I'll build like Hangman or something. And I eventually get to the point where I have a function that's like play, like just play the game. And at some point, I'm going to want like, so I'll have like my function play. And then in play, I'll check like, is game over? If it isn't, I'll just run play again, right? Which is like a list of like, so play will be like, ask the user for input, check if that input's correct. Did they do the right thing? Did they win the game? No, then just call play again, right? You can do it that way. You can also just write a loop. A couple of things about recursion that you should know. So you'll get used to how it works the more you play with it. But you should know these basic things. A function that calls itself, it must have a base case. That's what it's called, but that's your out, right? It is exponentially, it's less efficient than a loop, right? It is less efficient than a loop because the stack builds up, builds up, builds up, and it eventually becomes much slower than a loop. Anything you can do with recursion, you can do iteratively, right? Which is another reason why it doesn't get used that often. But it'll come up guaranteed in your interviews, so you're going to want to learn.
So I have a question.
Yeah.
If you, well, I just kind of want to see what would happen if you hit on the bottom example where we started.
Yeah.
If you hit print, or not print, but if you called say hello in say cool underneath, then it would break. But what would be the error you would get? Would it be the stack thing you said? Stack?
I have no idea what would happen. That sounds terrifying.
I mean, that's isn't that what you described as it?
Well, no, this is like, say
hello
hello is going to call a function, say cool, that then calls say hello, that is then calling say cool over.
Yeah.
I'm pretty sure it'll explode.
Infinite.
It will.
I just wanted to see what
it will
would say.
infinitely go back. You can try it on your computer. I am terrified about what it's going to do on my computer.
I think they will screen a stack when they either.
I'm pretty sure it'll just say stack level 2 deep.
That's what, yeah, that's what I see. So I can recognize that error.
Functions off.
So.
Would you print the type without the return?
Wait, what?
Or you were gonna test it for?
I am not going to test that.
No, not that specific thing she said, but the return. He asked if you could remove it.
Yeah.
What would be the type?
Let's just see what it would give us.
Well, the type of it is.
Well, hold on a second. Broke.
Yeah, see none type along the end. It says operating does not support int multiplication.
Yeah, so it's just gonna. Oh yeah, because it's never. None of these functions all the way down are ever gonna return it. So the 1 will get returned when we're at 1. It'll get multiplied, but then it will try to multiply it times none because the other one will return none. Yeah, it won't work. You have to return it. Cool.
Well, he said, so the 1 will return because it has to return 1, but then then it will try to multiply 1 against none.
Right.
Is that because we've already started we've already these functions are still in our stack, but they have no value. So it's
Right.
not returning
So
anything.
so when they're done running, when they resolve, unless we tell them to return a value, they I think by default they return none. That's what, if you don't tell a function in Python to return anything, it will return none. So it's returning none. So we are explicitly saying return 1. So when we get to 1, it returns 1. And then it tries, you can see on line 4, we're multiplying, right? So then what you end up getting is 1 times none, which you can't do. You can't do 1 times none.
Is none null?
Yeah.
Okay.
Same thing. Cool. All right. Let's take a look at what you have for today.